Good day, everyone. I'm Sarah Angel Caracas. Our topic for today is about miscellaneous substitution. Now, if the integrand is rational except for radical of the form, so n squared of au plus b, the substitution au plus b equals say raised to n will replace it by a rational integrand. So next, square root of q plus pu plus u squared. The substitution q plus pu plus u squared equals quantity z minus u raised to n will replace it by an rational integrand. Number 3, square root of q plus pu plus u squared equals square root of alpha plus u quantity beta minus u. The substitution q plus pu minus u squared equals alpha plus u squared, say squared, or minus u squared equals quantity of beta minus u squared, z squared. We'll replace it by a rational integrand. The substitution u equals to arctan z will replace any rational function of sine u and cosine u by a rational function of z. Since sine u equals to 2z over 1 plus z squared, using the right triangle, since sine is a opposite over the hypotenuse, we have her 2z as in the opposite of per u, and hypotenuse is 1 plus z squared. Using the Pythagorean formula, let your adjacent side, using this equation, you can say your b equals 1 minus z squared. Therefore, the adjacent side is 1 minus z squared, and your cosine u is the adjacent over the hypotenuse. That is why we have 1 minus z squared over 1 plus z squared, and the derivative of 2 dz over 1 plus z squared. Then the first and the second of this relation are obtained of the figure, and the differentiating and the kind differentiating u equals to arctan z. After integrating, use your z equals tangent 1/2 u to return to each original variable. Now we move to our example number 1. Example number 1. The integral of dx over x square root of 1 minus x. So let 1 minus x equal to say squared, and then x transpose to the right side, say squared minus 1, 1 minus z squared. Get the derivative of dx equals negative 2z dz. Therefore, we have now equal to, where the dx integral substitution, negative 2z dz over the value of x, that is 1 minus z squared square root of z squared. Okay, therefore equal to negative 2 in integral z dz over, simplifying the square root of z squared, we have 1 minus z squared times z, therefore cancel z, we have equal negative 2 dz over 1 minus z squared. Remember the formula, we have integral of we have integral of du over a squared minus u squared equals 1 over 2a times ln a plus u over a minus u plus c. We have integral of negative 2 dz over 1 minus z squared. Negative 2 over 2 times 1 ln 1 plus z over 1 minus z plus c. Therefore, we have negative ln 1 plus z over 1 minus z plus c. Negative ln 1 plus square root of 1 minus x over 1 minus square root of 1 minus x plus c. So that is our final answer. For example number 2, find the integral dy over y minus 2 square root of y plus 2. Let y plus 2 equals z squared and y equals z squared minus 2 and your dy equals 2z dz. Therefore, substitute the integral 2z dz over y minus 2 is z squared minus 2 minus 2. So, square root of y plus 2 is square root of z squared. Therefore, we have 2 integral z dz over -2 is -4, so z squared minus 4, then square root of z squared is z, so we cancel z. We have 2 integral of dz over z squared minus 4 using the formula of the integral du over u squared minus a squared equals 1 over 2a ln u minus a over u plus a plus c. That is equal now to 2 over 2 times 2. So this one z squared minus a is to 2 squared. Therefore, we have 2 over 2. A is 2. Ln u is z minus a, which is 2 over 2 plus 2 plus c. Therefore, cancel 2. Therefore, 1 over 2 ln z minus 2 over z plus 2 plus c. Go back to the original. We have equal to 1/2 ln square root of y plus 2 minus 2 over square root of y plus 2 plus 2 plus c. That is the final answer.